All right. Hello, everybody. This is our first webinar of 2022, and I am Craig McAtee, the Executive Director and CEO of the National Coalition of Advanced Technology Centers. We're happy to have two of our newer strategic partners with us today, Universal Robots and NewScale Robotics, and they're going to be talking about how they're integrating automated metrology into manufacturing education across the country. And there'll be plenty of time for questions and answers afterwards. But if you have a question during the presentation, please put it in the chat box and we'll save those up as well. Next slide, Trey. Just going to give you a 2-minute overview of NCATC. I see a lot of people on that I know quite well, and I'm so thrilled that you're with us today. Paul Perkins from Amatrol, Brian Wilson, thanks for being with us today. You're the chair of the ARM EWAC, Education and Workforce Advisory Committee, and we're so thrilled to have you with us. But NCATC's focus areas are 4. We call them our pillars. And the future of work with Industry 4.0 and now 5.0 and beyond, we just might as well call it X.0. Anything with smart automation and manufacturing is the top of our food chain. We've been focused on that for 15 years when mechatronics started 20 years ago with Toyota and beyond. And so that's our number 1 pillar. Our second pillar is work-based learning and training that goes with that, whether it's apprenticeships, internships, co-ops, or entrepreneurship. We believe really highly in focusing on that in the college systems that we represent. Third is competency-based education, where you can apply the knowledge and skills in the real world with real industry-recognized credentials and certifications. That's what we believe in. Seat time with credit hours, kind of a 20th century approach, even though we're stuck with it for a lot of reasons, but we believe in competency-based education where you can really focus on those skills and knowledge. And last but certainly not least is our adult learning opportunities, whether it's diversity, equity, and inclusion focus with underserved and underrepresented populations, all types of those populations we're trying to help get entry-level or better jobs in advanced manufacturing and IT. Next slide. We are made up of about 170 community and technical colleges across the country. You see the map here. But we also have 48 strategic corporate partners, and those 2 I mentioned that are part of our webinar today are a big part of that. Next slide. Before I turn it over to Tony Neary, who's going to introduce our guest speakers today, I want everybody here to know that we also serve on 8 of the 14 Manufacturing USA institutes on their workforce and economic development. Those are represented by the red triangles, or little hats as I call them. We started, of course, about 10 years ago with America Makes, focused on additive manufacturing, and migrated to LIFT, the Lightweight Materials Group, and MXD, which used to be called DMDII for Industry 4.0, all the way out to the West Coast with NextFlex, Flexible Electronics, IACME, the Composites Institute down in Tennessee, and Remade up in New York. We've also, of course, got ARM, who's sponsoring and supporting this adventure today. I'm going to introduce you to Tony Neary. Tony, come on, and we'll put up the next slide for you to talk about our strategic partners that I mentioned. And then she'll kick this off by moving us into our webinar with our presenters today. Tony Neary from the Morris Group and Haas Automation. Thank you, Tony.
Thank you so much, Craig. And as Craig mentioned, I'm a proud strategic partner for NCATC. I've also sat on the NCATC board as a strategic partner for almost 3 years now. And it's my honor and privilege to talk about our strategic partner network. These are the organizations that make us better as educational programs. So we have everything from actual hardware to software to solutions that can help make that workforce development pipeline even more efficient. I'm here today to introduce our newest strategic partner, NewScale Robotics, and we have Stefan from there, as well as Corey from Universal Robotics, one of our additional newer strategic partners. And as we look at Industry 4.0, it is here. This is real. This is happening now. And we want to talk about real solutions. Stefan joined NewScale Technologies in 2016, supporting sales of precise micro mechatronics products, later moving to the NewScale Robotics division in 2018, where he's now their product manager. manager. He works closely with manufacturers to automate dimensional gauging and inspection tasks and has built partnerships with Universal Robotics and gauge manufacturers to support this type of automation with collaborative robots or cobots. He also works with educators to help students develop new skills in robotics, part handling, and metrology automation by bringing together different technologies and hardware with robotics curriculum packages. And he's joined today, as I mentioned, by Corey, who is based in Columbus, Ohio. He has nearly 10 years in industrial automation industry experience. He's the educational program manager for Universal Robotics and specializes in education and workforce development. Prior to joining Universal Robotics, Corey worked in project management and technical sales for an industrial manufacturing distributor and robot integrator. He also honorably served in the U.S. Coast Guard and holds MBA degrees from Keller University in finance and marketing. So I think we're in really good hands with these two gentlemen to share for us today. So without further ado, I will turn it over. If you do have any questions, please drop those in the chat box. We'll save those for the end of the presentation today. And thank you so much for joining us.
All right, does my screen transfer go through?
We got you, Stefan.
Perfect. All right, well, thank you, Tony and Craig, for the introduction. Corey and I are happy to be here. And yeah, special thanks to NCATC for hosting us today. I will jump right in since we already went through introductions. So this is our agenda for the presentation. We're going to talk about collaborative robots, how they're changing the manufacturing industry, and why the use of collaborative robots in quality inspection specifically is a growing area of importance for a lot of manufacturers. We'll also go through some industry trends and some current challenges in manufacturing and quality, and dive into some real world application examples and case studies on the industrial side of things, showing you how employees can add value to their company by adding automated inspection directly to the production floor, and also the benefits of automating offline inspection more within the quality lab or the metrology lab. I have a bunch of different application examples and videos we'll go through throughout, and hopefully you guys can learn about some new applications. And then we'll also jump into the new curriculum and training programs that are available that we're trying to help provide colleges and other institutions the ability to educate their students about robotics and quality and help them develop some new skills to make them more valuable and employable members of the workforce. So, you know, a new paradigm in manufacturing is the use of collaborative technologies that give everyday employees access to automation. It's, you know, I think well known by everyone that future manufacturing jobs are going to require automation skills. And those new automation technologies are really becoming more accessible to small and medium-sized manufacturers, and lets those everyday employees use the technologies to automate repetitive processes. And this has really opened up to those people because there's easier interfaces that emulate some of the typical app-based technologies we use every day, like smartphones or basic computer programs, while also allowing side-by-side operation with robots, usually without guarding or barriers between the employee and the robot. And one of the core technologies that's enabled this collaborative, agile, or flexible manufacturing automation are collaborative robots. And today, these collaborative robots are the fastest growing segment in the industrial robot space. You know, small and medium-sized manufacturers are where most manufacturing students will end up in the workforce post-graduation. And those are really the businesses that are going to benefit from these new collaborative technologies because the barrier of entry is lower due to the technology's ease of use. There's really great training programs that gives operators hands-on time. And there's also a big range of different plug and play tools that makes deployment faster and a lot easier for for those production staff that are actually implementing the technologies. Cobots are, certainly helping non-engineers like production staff, inspectors, technicians, machinists to use these automation tools daily, really as a tool that they would use for anything else, and help them add value to their employer, with all the normal benefits you get from automation, like increased throughput, reducing production errors, and lowering costs. Our CEO, always says that he thinks in the near future, someone's going to come to work and they're going to say, just like you say today, well, where's my laptop? I need my laptop to do my job. They'll say the same thing about a robot. They come to work as a manufacturing employee and they expect to have a robot to be able to use on a day-to-day basis. So I'll pass it over to Corey here, and he'll walk us through some of the basics of collaborative robots.
Yeah, thanks, Stefan. So just real quick before we dive into the full presentation here, we just want to make sure that everybody understands when we're talking about cobots, what a cobot is and how we see them in industry, right? So cobots, better known as collaborative robots in industry. Cobots have kind of been known for being very safe and able to safely work and operate around humans, right? So universal robot focus is developed through force and torque monitoring. So anytime that we see a spike in a force or torque, say, bumping into a shoulder, bumping into an individual, the robot gets put into a safe halt. So that's kind of where we see the difference between industry and collaborative. We also see that collaborative is 1/3 or 1/2 that of traditional automation, because you're able to kind of remove a little bit of that safety factor away from industry. But it's also, I think there's another thing here. It also creates a very safe space for a student to learn about robotics, right? You're able to put these on a desktop and know that you put this thing at 100%. It's not going to cause any bodily harm. And then lastly, human robotic collaboration actually proves to be 85% more productive over than if that was just a human and or a robot. Our philosophy in 2022 for universal robots is we want to create a world where people work with robots and they don't work as robots in manufacturing.
So here's one sort of typical example you might see, where 3 of these robots are working side by side. This is for a food packaging application, and you'll notice that there's a person standing right in the middle of 3 robots, and there's no guarding. But the robot is well within reach of the worker. So because these collaborative robots operate within these small profiles, and they're easy to be deployed, repurposed, and redeployed, when compared to more traditional industrial robots, they're usually used in a lot of higher mix applications where the volumes are a bit lower per production run, and the mix and variation on a day-to-day basis is a lot higher. It's not the same widget is being produced in the millions per day. It's more of the type of manufacturing processes you'd see in smaller, medium-sized companies. So we'll take a look now at some of the the challenges and problems we're seeing in the market today that's really driving a lot of companies towards automating, either automating more or just starting to get into automation. So by far the biggest challenge that I think Corey and I both hear about from our customers is the labor shortage. And there's definitely a lot to talk about there. And Corey is going to walk us through that in the next few slides. But we're also hearing that manufacturers just have, specifically related to quality, they're seeing too much variation in their measurement techniques from operator to operator. And this might just be because of a lack of training, the tools that they're using, or the techniques that operator's using, or it may just be a bad operator. But the benefit of automating those tasks is that the robot's going to inspect the part in the same way every time and remove that variation, while also collecting digital data that they can make process improvements with. So we're really seeing that these small businesses are being forced into either considering automation for the first time, or they've rapidly accelerated their plans to automate because they either can't keep up with their current production levels, which often creates a bottleneck in their quality control department. And or they just can't find enough people to produce and inspect the products that they make. And, a lot of the time it's not neither or. They're dealing with both bottlenecks because they can't keep up with the volumes they have to produce. And, that's in part because they don't have the people to do it. So historically, automation's really only been accessible to larger manufacturers that have, tons of resources, teams of engineers to integrate these solutions. And we're seeing this change already. So it's important for the new workforce to be prepared with automation skills as they enter the workforce themselves for the first time. And I think this research from the MIT Task Force of the Work of the Future does a really good job of showing the gap that these cobots are trying to fill for smaller employers. So they found that, quoting here, in the early 1970s, the productivity measured in shipments per employee of large manufacturing establishments, which they describe as plants with over 500 workers, was only about 22% higher than in plants with fewer than 500 workers. By 2012, revenues per employee at plants with more than 500 workers were 96% higher than those at smaller plants. Trying to explain slow productivity growth in SMEs and what appears to be their worsening relative performance seems a critical step in understanding the future prospects of U.S. manufacturing. When, why, and how manufacturing firms acquire new technology, how they find or train workers with new skills, these issues are central to figuring out why productivity lags in smaller companies. So I think these, larger firms have gotten so far ahead because they've used their resources to invest in those new technologies and training, particularly in automation. And since there haven't been really great ways for these smaller companies to keep up, because the technology was just sort of inaccessible to them, it's really helped the bigger technologies get further ahead and get further ahead faster. But we see these new, easier to use systems as a way for the smaller and medium-sized companies to keep up and close that gap.
Thanks, Stefan. I'll go ahead and just kind of quickly talk about the labor shortage here, and you kind of see some quick blips here: impossible to hire, expensive to cross-train, and difficult to keep. Anybody who's talked to anybody in industry, that these are kind of the things that you start to hear: impossible to hire. But what does that mean, right? What does impossible to hire mean? I mean, we hear of all these manufacturers having workforce development programs out there, but how are we not doing a good enough job in addressing the need? It's because when we talk to industry, it's not impossible to hire. There are people there, but there's not enough skilled people there, right? A lot of the training that we see in place today is not that of workforce development training, but it's that of product training, right? Learning how to use a particular manufacturer's equipment. That's not really solving the issue because, there's not just one particular manufacturer that goes into developing an automation solution. Expensive to cross-train. Well, we wanted to kind of dig into that too. Well, when we talk about product-specific training, well, I've got to go to XYZ manufacturer to learn how to use their software. I've got to go over here to learn how to use that to communicate with this. So there's a lot of, so you're starting to understand that there's not just one path for an individual to take. And then, like you see, difficult to keep. So if they were able to hire the appropriate individual that had the skills, or they hired someone who wanted to go out and attain the skills, well, now it's difficult for them to keep because they have a very rare commodity, right? A well-trained employee that now sees their value at this point. So, that kind of looks at, okay, how did we start to see that? And then, we started to make those strides, and then COVID happened. Right. And everybody knows how COVID kind of affected that. And we see short-term 30 million unemployed. That's a lot, right? Record-breaking unemployment will not translate into skilled committee manufacturing workforces. Thank you, Stefan. Appreciate that. And then major issues with the skills gap, training costs and career preferences. So we kind of see food services in manufacturing, retail sales in manufacturing, hairstylists in manufacturing, dental hygienists in manufacturing, auto sales in manufacturing. Where are some of these going to go as the skilled workers leave? And the skills workers being, the boomers, right, and being replaced by Xers and Zs. New studies have come out showing that by 2030, that number is not 30 million. That number is 200 million in the US. And we as manufacturers need to start to work together collectively and collaboratively, no pun intended, to start to address that of providing a skilled workforce, not a product skilled workforce, but a skilled workforce in automation. Next slide, Stephanie, if you could. So, manufacturing is not a staffing issue. It's a short-term issue. It's also a demographic issue, right? So, next slide, please. So when we look at that, we look at the boomers and millennials, right? So 10,000 boomers reach retirement age every day, and we've seen forced retirements come down from COVID. Millennials and Xers not interested in filling manufacturing gaps left behind by boomers. Some of that, from what we've seen, is that there is a misconception about what manufacturing is today. ARM, I believe Brian is on here. ARM shared a great statistic with us during our meeting, and it was, over 50% of parents understand the importance of manufacturing, but less than 15% actually want their kids to go into that space, because there's a misconception on what boomers, when boomers went into manufacturing, what it was like now. It's still dull, dirty, and dangerous, but we're making it a little less dull with automation. With automation, we're also making it a little less dangerous, right? So there's a lot more excitement there, and it's a lot cleaner, right? You don't get the smell of fiberglass. Some of these floors are cleaner than my kitchen floor. So there's not only a misconception between boomers and millennials there, so there's a lot that we needed to start to digest. Next slide.
Yeah, and just to comment on the labor crisis as well, I think it's important to note that with less staff, excuse me, and business owners trying to grow their businesses, those management teams are going to keep putting more pressure on their existing employees to increase output, but with less human capital. So I think the use of automation is, going to be very necessary to meet these new challenging production and performance demands, really to keep up. So another industry trend that we're seeing is the desire to collect more data in the manufacturing process. There's definitely huge demand in the manufacturing industry to collect data in really every aspect of the production process, particularly quality control, to drive process improvements and really make better decisions. There's definitely situations where you can overdo it on the data. The main thing to keep in mind is it has to be actionable data that you can actually make improvements from. Otherwise, you're just collecting data for the sake of collecting data. But one interesting thing that I saw recently in an article in Quality Magazine is Infinity QS spoke with 260 manufacturers about their data collection. And they actually found that 75% of the people they surveyed were still collecting data manually, and that 47% still were using pencil and paper. So it's just kind of interesting with the amount of buzz around digital data and digitizing things, that there's that many people still doing things so old school. Usually where we see a lot of digital improvements is in regulated industries, where you really need to make sure your data has a high level of integrity, particularly medical or aerospace type industries. So using robotics to help automatically record and store that data not only improves the accuracy of data collection, but it also reduces the likelihood of falsified data, and also helps them avoid non-conforming inspection ratings. So we're starting to see more and more manufacturers recognize that they need to digitalize data, and are searching for solutions to tie all of their production together on the back end. Final trend that that we're seeing a lot is the need for easier to use automation solutions and quality control technologies. It's automation and robotics are definitely seen as, it's a good way to fill the labor shortage and fill that skills gap. But it's interesting too, because it's also a way for companies to both attract and retain workers. We actually hear that a lot, because their employees want to feel and see on a day-to-day basis that their employers are really on the cutting edge of technology and they're using it to their advantage, as a way to keep them competitive in the economy. We're also seeing a need for more, safe for human technologies like cobots, but also autonomous mobile robots and smart conveyors in factories that will keep workers safe without having to take up a huge amount of floor space, which, oftentimes is a lot more limited than you would think in these facilities. And then, we're also seeing a lot of bottlenecks in quality departments, especially in metrology labs. Most companies, particularly those with limited automation experience, want to see what we call the appification of automation, as well as their inspection systems they're using. Make them as easy to use as possible, easy to teach, easy to learn, easy to redeploy, really just like the apps on our smartphones. So we'll jump through some application examples with real customers solving real problems here. So this is I think a good sort of good overview of what we've been talking about. This video here. So we find a lot of the time when we're talking to manufacturers, they don't really have a firm grasp on how much time they spend on quality and inspection. And I think that's because their team has to complete so many different manual inspection processes throughout the day. And it's usually baked into the production process. So, a lot of the time machinists, CMM programmers, other high paid production staff are doing these, day-to-day inspections on the floor. When you have a really highly skilled and highly paid operator like a machinist, freeing them up from inspection tasks lets them spend more time making parts and less time inspecting them. And that's really a big value add in the manufacturing space. Got to maximize machine uptime. And because these inspection tasks are usually completed by all sorts of people, it's really important for anyone in manufacturing to have a really strong foundation in the principles of metrology, inspection, and the function of their quality department. So the system we're showing on screen is from NewScale, and it's using Universal Robot. Basically, these grippers are functioning as robotic calipers. So they're picking parts and placing them, but they're also inspecting them at the exact same time. And it's really the basic concept we've been describing. It's automating it, about the same speed as a person, taking up about the same amount of space that someone would need to manually inspect parts at a bench without guarding, but also improving the measurement process and the repeatability and automatically collecting all the data. Freeing those operators up to do more value add tasks for the company. So, just quickly, traditionally, we see two primary inspection methods in the manufacturing space. So, method one is more inline inspection on or near the production floor. Usually this is done with manual tools like the caliper you see in these two photos. You may have data recorded digitally, automatically, or you may have, you may be writing things down, pencil and paper, like you see on the bottom right. They're really good. These tools are really good for, checking parts quickly in reference to a drawing, making sure things are in spec, but using them for hours on end all throughout the day is not just prone to error, but also prone to turnover. People just don't like doing that.
Right.
And, inaccurate measurements for manual tools or forgetful operators who, might accidentally leave a machine running for a really long time. without going over and making those measurements and process adjustments they need, that can lead to failing batches of junk parts that maybe need to be reworked or totally scrapped. And both of those are unnecessary expenses. Or you might end up with good parts that are rejected, some bad parts that ship to the customer, or there's not enough data captured to let you improve the production process.
Yeah, real quick, Steph, I just want to point out one thing to everyone listening here. When you've seen the one video, you had someone sitting there with manual calipers checking and writing down all the proper, measurements. We're not only we're improving someone's livelihood as well, right? So that's a job that Stefan mentioned that not a lot of people want to do, right? I don't want to with a pen and a paper and just measure, and so we're increasing someone's livelihood and giving them a better job. So when we go back to that dull, dirty, dangerous, this isn't dull or dirty or dangerous, but it's a job that is nobody really wants to do, right? So we're increasing that by collectively coming together and providing a solution around that.
Yeah, and the same thing applies in the more within the metrology lab itself, where you have much larger specialized pieces of advanced inspection equipment. Here we have, a CMM on screen coordinate measuring machine. You might have vision systems or optical comparators that are used in the metrology lab as well. And those are really great tools, very specialized, very precise. And they really exceed any tool that you'd be able to use on the floor, hand tool like a caliper or a micrometer, or even something like a bore gauge. This type of inspection work usually involves programming the machine and setting up fixturing, and then it just becomes a process of loading parts in and loading parts out of this pre-programmed inspection cycle on the machine. And that's usually repetitive enough where that's also a pretty good candidate for automation. That, routine loading and unloading is, again, usually performed by someone that's highly trained and well paid. They might be an inspection technician or a CMM programmer that's spent a lot of time on these more advanced inspection tools. And their time's really just not best spent doing this sort of loading and unloading operation. So we're definitely, seeing a lot more interest in automating those types of tasks as well. So rather than have someone sit there and load parts in and out and monitor the process, they can load a tray, hit play, have the thing run, and, go do something else that's more productive, like programming another machine, or doing other inspections that might just be better suited for a person to do. This is, let's see if I can get this video to run here from YouTube. So, this is a kind of in-process machine tending example. And we see, the best manufacturers and the best employees really embed quality improvements into every business decision and manufacturing process, which is why it's so critical that students understand this early in their careers. And, that's true of what we do at NewScale too. We try to embed quality just into the culture and everything that we do. So one of the advantages that we're showing in this video here is automation brings gauging closer in time and location to the production process. So this really lets you measure either in the QC lab with real-time data sharing, or in this case, we're gauging parts near the machine and combining it with a machine tending operation. So as you're running like a CNC machine, you need to inspect parts periodically to verify that they're being produced within tolerance. And this really helps the machinist pick up on process changes. So, like if tooling has started to wear out on the machine, a change in a dimension will open their eyes to that and tell them that they need to go in and service the tool or adjust an offset on the CNC machine. So by doing this automatically, you can really significantly cut down on scrap and rework rates because you have instant data. You can measure up to 100% of parts, which, a machinist is not going to be able to keep up with if they're in charge of running, 3 or 4 different machines in the day. It is even possible to make a closed loop system where you are inspecting the dimensions and sending automatic tooling offsets to the machine itself, and adjusting that process in real time. That's a little bit more advanced, but if your goal's to do lights out operation, it's certainly possible to do. So, kind of rather than having this goalpost mentality where a part's either a pass or a fail, on either end of the tolerance range on the dimension that you're machining, you can keep the dimension closer to nominal in the middle, and make sure you have the best part possible every single time. This is a kind of a similar example, but more in the optics space. And so this is with OptiPro Systems. They're using a UR3E cobot here, with the robotic caliper to inspect the dimensions on a large stack of cord lens blanks. So in this application, they're basically taking large stacks of laminated glass, they're boring them out, and that produces a bunch of different lenses at one time, lens cores at one time. They basically use as blanks later in the optics machining process. So here they basically just load an input tray into the inspection workstation, which is a little different than the single part feed that we saw in the last application example. But a tray like this allows you to just, set the tray down, you hit play, and then you can walk away. Same sort of thing. It's, helping you monitor the process, reduce scrap, improve yields, and eliminating the need for that person to sit there and, measure trays of these things all at once. And this is actually also at OptiPro. It's like use it on the floor, and then we wheeled it in the metrology lab. Kind of going back to that picture I was showing before of loading and unloading a CMM. So, there's a lot of manufacturers we speak with that are dedicating more inspection work to their quality labs to meet the industry's growing demand for stricter QC requirements and more data. And that can often lead to bottlenecks in the QC labs that are really unnecessary and expensive. So, when you're committing your CMM, you're probably your most expensive piece of inspection equipment in your facility to measuring a huge range of parts that don't necessarily need to be inspected in the lab. There's really a big opportunity cost there for dedicating that valuable piece of equipment to higher volume routine inspections that you could either, automate or, probably be doing right next to the production line with an operator. And just for some context, a CMM programmer typically is paid in the range of $25 to $30 an hour. So, the cost for implementing this type of machine tending is comparable to the annual total cost of 1 to 2 full-time CMM programmers. So, just to kind of give you a sense of scale, it is an affordable solution for a lot of these smaller companies that are already paying these people, quite a bit of money per hour to do these types of load and unload applications. So we're, really reducing the barrier of entry there. This video, shows more of a manual gauge load and unload. In this case, it's an air gauge. Air gauges are extremely accurate and reliable technology. They're kind of older technology. They used a lot in automotive applications at first, and they're really good at making fast measurements with micro inch precision. And, if you're working with industry like aerospace, auto, medical, a lot of them probably use these types of gauges on a day-to-day basis. So usually when an operator does it, they kind of have to wiggle the part on because it's a very tight clearance. And, this application here just shows, you can have a robot do that type of load and unload with the very tight clearance and kind of bring this old technology, into the 21st century, if you will, and get all those normal benefits you see from collaborative automation. It can also work in tandem with other machines to automate part picking, part placement, while doing inspection and meeting those high precision requirements. And same thing, as I mentioned earlier, the controller I'm showing on screen, you can tie that in with the robot controller and actually export the data digitally, just like you would be able to with other tools in this workstation. So look at some of the solutions that UR and NewScale's developed, specifically on the workforce development front to try to build some of these automation skills we've been talking about.
Yeah, thanks, Stefan, for showing what customers are trying to do to help with the QC or quality inspection. So we'll take a quick journey here. So early 2020, I was a business development manager for UR and seen a major gap within workforce development working with some of our educational partners. So in doing that, I started to kind of reach out to organizations like NCATC. Thank you, Craig, and we're happy to be a member with UR. And then we started working with other organizations, Tooling U, SME, and ARM, who endorsed our educational offering in early 2020 that we launched. And the whole reason we wanted to start this path in education was we wanted to make sure that we were developing a foundation for these individuals. So as the market changes, so does the training, right? So Stefan brought up high mix, low volume, right? How many times does Apple come out with a new phone in a year? Or how many times do they come out with a new watch, right? So we don't see product runs running nearly as long. So we're seeing more of those low or high mix, low volumes. So we needed to start to look at the way that we address the training. We also needed to understand that a robot is just one tool in automation. We've seen all the manufacturers that have worked with the QC and new scale product, and all you see is a robot moving from one point to another, right? All the other ancillary items are actually doing all the work. So we wanted to start to review all those different aspects of automation. And when we developed our program, we wanted to find a way that we could start to develop an individual's basic automation competencies, because we feel that's really what sets them on a strong foundation for success in the automation world. Next slide, Stefan, please. So what did we do to start to do that? Well, we wanted to work together to provide a cross-platform training, right? So UR can only bring so much to the table. So we started to reach out to some of our partners. NewScale was one of the early adopters of our educational program. So we co-developed an application specific training for those QCs. So focusing on helping the industry, helping the incumbent worker, but also helping the individual who may not take the traditional college path, but be able to receive the skills that industry is looking for. And to ensure that training is up to date for both staff and students. A lot of what we see in training today hasn't been updated since the early 90s. And the importance to know that we're using industry recognized components, right? That when they go into industry, that it's going to be the same thing. And there's a comfort level there for the student when they move into the manufacturing world that, hey, I'm familiar with this. I know what I'm doing, right? So where does that kind of lead us? That kind of led us into taking our core offering as the basics of developing an individual's foundation and partnering up with NewScale, who can specialize in the QC function. So when you look at the educational program that Stefan's going to share with you with NewScale, not only are you going to receive an industry credential backed by Universal Robots through our core offering, which will run you through not only not programming UR, but programming of a 6-axis robot. We're going to talk about the importance of inspection. We're going to run you through force torque sensing. We're going to talk about palletizing. So we're truly trying to introduce you to some of the most basic foundations you're going to see within developing an automation solution. Go ahead, Stefan.
Yep. So, as Corey was mentioning, there is a robotics curriculum that's available for both the Universal Robot, and then we use the QSpan Workstation kit as our, and that's what's showing on screen, is our foundation for teaching students about the fundamentals of metrology and inspection. So the packages provide students with accredited training in certain topics using specific equipment. And it gives students more skills to showcase when they're looking for employment, and gives the employer more confidence that those new hires can be productive sooner, and kind of lead them through how to use and deploy automation technologies. But I'll just run through the kind of list here. It is training that's, is meant to be used on the job. So while it is a product training in a sense, they're using certain equipment. The goal is to help students develop those foundational skills in automation and quality, and help them prepare to apply those skills when they actually enter the workforce. And hopefully that does, open them up for more job opportunities with some of those credentials that they'll gain. And our goal is to help them understand quality control tasks in industry settings, while gaining experience, hands-on experience with, collaborative robots and, some of the technologies that are being used on a day-to-day basis in new manufacturing facilities. So, I probably should have explained this earlier, but for anyone that doesn't know, metrology is the study of measurement, and that's really what we dive into in our curriculum. So it includes things like the definition of units of measurement, validation of measurements and traceability to align measurements to standards, and of course the practical application of using robots to automate metrology tasks. Whether you use UR's Academy Training Simulator, you can take just the metrology course on its own, but we always recommend running through UR's educational kit, where they really get the best core experience of operating a robot, learning about automation, and how they can bring that into work with them when they're ready to enter the workforce. Corey, you have anything to add about the kind of specifics of the UR educational kit?
What kind of falls under the educational kit? Outside of what you're going to get with NewScale, you're going to get a robot, you're going to get some 3D printed work pieces, and you're also going to get a conveyor as well, like a little mini conveyor, because we want to start to show you parts coming in, parts going out, palletizing, showing to an inspection camera or to an inspection QC for provided by NewScale. So there's a lot of different things that we're trying to cover all within one easy turnkey solution.
Great. I don't know if anybody has any. That's kind of all we have for the formal presentation. If anybody has any specific questions, we can certainly dive into those. Looks like we've got about 10 minutes left or so.
Yeah, we actually do. We have a question from Paul Perkins, and he wants to know what kind of robot position repeatability is needed to load and unload air gauges, considering the gauges have such tight tolerances.
Yeah, that's a good question. So the UR robots range in position repeatability from 30 microns to 50 microns, depending on which robot you're using. Usually at NewScale, when we're doing inspection applications, we are using the two smaller robots that have the 30 micron repeatability, and that has been more than sufficient to load and unload air gauges. So I don't think we've tried loading air gauges with the repeatability, the robots with repeatability of about 50 microns, but I'm sure we would be able to do it with those as well. But the UR robots have been more than sufficient.
Perfect. And then do you have any examples of successful coupling of K through 14 education, workforce development, and industry?
Corey, do you want to take that?
Yeah, so on the UR side, absolutely. So UR has been doing a lot within workforce development. We've, since the launch of our program in 2021, we've had over 40 schools take part of the program. That ranges from anywhere from vocational schools, so your high school level, all the way up to your post-secondary, to your four-year university, and also to your university college levels. We do have a plan to get into the K to grade, which many of you have heard. So get into that middle school and younger generation as the year progresses.
Fantastic. I would like to say thank you both for joining us today. This has been so informative, and I feel like I definitely know more about robotics and robotic integration. So I think amazing.
Always a pleasure, Tony. Thank you very much.
Oh, here we go. One other question. Does the end effector have any float or soft positioning when loading close fit gauges?
That's a good question. We don't, we don't. And we found though that the repeatability of the robot has been enough to get us to load into gauges. It's, things with more of a, that are more mechanical gauges, that are actual contact gauges, like bore gauges. Those are probably the most difficult to load, but we find if we design the fingers in such a way that it makes really good contact with the part, that we don't have any issues loading or unloading those types of gauges. And we'll also do, if you're loading a part onto a bore gauge, we can also do sort of a rotating motion with the robot arm, that allows us to kind of emulate what an inspector would be doing on the floor. But no, there's no like floating or soft positioning. They do have vision guided systems with robotics, but that kind of help with those little micro adjustments. A lot of the times those are used more in electronics type applications where precise positioning of components like on a PCB board is really critical.
Fantastic. Well, thank you again. You can see Stefan and Corey's contact info available on the screen. And so far, the feedback has been great presentation. I'm sure a lot of people will catch on the replay. And if you do have any additional questions, please feel free to reach out to Corey or Stefan.
Thanks.
Thanks, everyone. Thanks, Craig.
Thanks so
Thanks,
much,
Tony, and thanks to NCATC for hosting.
Yeah, thank you all.
Thank you.
Thank you.
Have a great day, everyone. And thanks, Corey, Tony, and Stefan for this great day today. And all the attendees, we will have the recording on our website in the next 48 hours. And looking forward to keeping in touch with all the great success you have moving forward. And as we share best practices with our network on schools you're working with, we can then make this grow faster than ever. So thanks again for all your time today. And we'll see you in the near future. Stay safe, everyone.